All right, let's get this loaded here. Okay, so today you guys are going to take notes on annelids, the segmented worms. Of course, we've been talking about these, but we just need to jot a few things down. Segmented worms, of course, are coelomates. You guys predicted that before we even started this phylum. The segments are created by something called septa, which are internal body walls. These segmented worms also have bristles along their bodies, which are called setae. That's plural. It's a Latinized spelling. One seta is one bristle, and setae is plural, meaning many bristles. As far as organ systems go, they do have a closed circulatory system, but they get oxygen through the skin. They have nephridia. They have a highly specialized gut, and that is an advantage because there are different regions to perform different functions. Of course, you know what those are after having done up close earthworm and gone over all the different portions of that specialized gut. Just to show you, this will be the inside of an earthworm, and the little lines that you see would reflect the rings on the outside, and those are the septa, the internal body walls. That's what they look like. They're classified according to the presence or absence of setae and parapodia. Parapodia, you'll recall from your reading questions, are fleshy-like appendages. And so based on the presence or absence of these two structures, we put them into three classes. So here's a picture of our first class, the marine segmented worms. There's another picture. And another picture. Not all of them are tube worms. This is a worm that we'll be looking at in our dissection called a clam worm. The first class we're going to talk about are the polychaeta or polychaetes. The CHAE is pronounced key. These are the ocean-dwelling or marine segmented worms. They have parapodia and setae. The setae are extensions of the parapodia. Some examples include tube worms. Only the head sticks out to trap food particles. This is the clam worm. We're going to be doing a side-by-side dissection with this guy and an earthworm. So the clamworm belongs to the genus Nereis. They're free-swimming and predatory. They actually capture their prey with strong jaws, and they can thrust out of the pharynx when they're getting ready to feed. We'll look at that more closely in the dissection. Next, we have earthworms, probably the example of this phylum you're most familiar with. Earthworms belong to oligochaeta, or the oligochaetes. Typically, we'll just call them ollies and pollies. These are earthworms and some freshwater worms. I'm not too concerned about those. They do not have parapodia. As you can see, there are no fleshy extensions, and they do have a few setae. They don't have eyes, but they have light and touch, moisture, sensitive organs. As far as movement, we're going to watch a video on this. The circular muscle surrounds each segment and contracts, and what that does, it makes it become thinner and longer. Then the longitudinal muscle extends from one end of the segment to the other, and it becomes shorter and thicker. And so the setae help anchor the worm in the dirt and help it move. And I would like you to draw a little sketch in your notebook of how these two muscles work. It's real simple. You can just draw a square, and then you've got your little circle muscles and your longitudinal. So you might want to pause and do that at this time. Movement occurs when waves of contractions with these longitudinal and circular muscles cause a bulge to form, and basically we can watch that bulge progress from the anterior to the posterior end in the direction in which it is moving. Last but not least, our favorites, the leeches. Leeches belong to the class Hirudinea. They do not have setae, they do not have parapodia. The body's more flat, and the segments don't have septa on the inside. Very few are parasites. Most are like scavengers and stuff, but these parasites do have suckers at the oral and posterior ends. And they produce a substance called hirudin, which is an anticoagulant, which means that the blood doesn't clot. And they produce that in their saliva, which allows them for continuous feeding. Medicinal leeches we looked at a little bit already, but just some additional information. They're used in tissue grafts and reattachment surgeries. Their anticoagulants prevent blood clots and relieve pressure. A leech saliva has other therapeutic properties, which include reestablishing blood flow. It's a vasodilator, which means it makes the blood vessels dilate to increase blood flow. Provides a numbing anesthetic. And also it has an antibiotic present, which helps decrease risk of infection. Got a couple pictures for you just from after some reattachment surgeries. So what they do is they put the leeches on either side of the attachment area, and the things that we just mentioned help establish blood flow, anesthetic, decrease rates of infection, and just generally help those vessels reestablish and heal. Well done, that's the end.